In this video, we are doing a quick introduction to trigonometry. We'll look at the six basic trig ratios, look at determining angles and sides of a triangle using the trig ratios. We'll also just look quickly at exact values of some trig functions. And then we'll conclude looking at a different way of measuring angles, not just decimal degrees, but degree, minute, and seconds. So to begin with, just a quick introduction to trigonometry and the use of it. Say you've got a boat out here. I'm not good at drawing boats. And the lighthouse wants to know how far it is. So the lighthouse knows how high the lighthouse is, and they can determine the angle that they can use to find or to see the boat. And because of that, they can figure out what this distance is here. If you're looking at GPS, I'm just buying myself a new GPS watch. I'm excited. But if I want to find my position anywhere on the Earth, they use triangles to do that. So they've got satellites up here. Are those satellites? Satellites up here, and they use an idea known as triangularization, and they can determine where you are from that. But it's based on triangles. So if the satellites know how far they are apart, and they know the angles to get down to where you are, they can figure out where you are on the planet. Okay, so just looking at a basic triangle, here's a basic one. We have some traditions or customs that we use to label the triangles, and these are helpful when we're solving any questions. So first off, to label a triangle, typically we have the right angle as angle C. And the right angle, usually we put a little box there, labeling that as angle C. And then angle A and B can be any of the two other angles. It doesn't matter. Notice that the angles are written as capital letters, not small letters. Now the letters that go along with them, like if I have angle A up at the top there, then side A is the one opposite to it, down there. Similarly, if I want to find side B, here's angle B, it's the side opposite that one over there. And so C has to be the side opposite angle C. So that's how we can label the actual sides, but sometimes we want to know which side it is in relation to where I'm at. So often I'll pick an angle, and I either pick A or B. In doing trig, we don't ever pick angle C. So say if I pick this as my angle theta, then I can also label the sides not just with a letter, but with a name. So if that's my angle that is in question, that's how I say it, then the side that's directly opposite it over there is labeled the opposite side. And then the one that's right beside it, now notice there's two right beside, but there's something special about this one. So this angle that's beside it is known as the adjacent side, and then the longest side, or the side that's opposite the right angle, is known as the hypotenuse. Also, there's a useful tool that we can use to determine lengths of sides, or the relationships beside them, and that's this here. You've probably seen that before as Pythagoras. So why don't you try labeling this side, or this triangle. I'm going to put the angle right there, okay, and see if you can label which side is adjacent, opposite, and hypotenuse. Pause and then press play. Okay, the side opposite the angle is called the opposite side. The longest side is always the hypotenuse, and the adjacent side is the one, I guess the other side that's not there. Okay, hopefully you did okay in labeling those. Now looking at a triangle, and if there's three sides, we've got different ways we can relate those sides, and they're known as the trig ratios. So you've heard of these before, you've used them before. And the sine ratio is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tan of an angle, that's the name that we call the relationship between opposite and adjacent. Some people have used this acronym kind of thing to help them remember the SOHCAHTOA thing, And if that helps you to write that on each page, you can do that. There's also reciprocal ratios. So these ones we call the primary ratios, and these ones are the reciprocal ratios. And reciprocal ratios aren't used a ton. I guess they're used quite a bit, but typically on your calculator you've got sine, cosine, tan buttons. You don't have a cosecant, secant, and cotan button. So that's why these ones are called the primary. These are reciprocal. They have their place, but they're not used as much. If you want to remember those ones, they're cho, sha, cow. I made that up. Just another nice relationship that we'll need here in a few minutes is the relationship between the sine and cosine. So notice I put these ones together and they're related. So sine and cosecant are reciprocals of each other. And this is how you can say that. So cosecant is a reciprocal of sine. You could also do it the other way, that sine theta is the reciprocal of cosecant theta. But typically we're using these relationships there. So secant is reciprocal of cos, cotan's reciprocal of tan. This one I always remember easy. The other ones I had a hard time remembering until I thought that the letters are different. So the reciprocal letters are different. So cosecant starts with a C is reciprocal to sine, which starts with a different letter. Secant starts or is reciprocal to cos. Okay, so we often will be given one ratio and need to find the other ratios. And so here's an example where they're asking us to do that. They say the sine of an angle is 1/2, and they want to know all the other ratios, all these over here. And I'll maybe write my answers down right beside there. So if they tell me that the sine of an angle, the ratio is 1/2, maybe let's set this as my angle. So the sine is 1/2. So this side over here will be 1. Let me just write this. Sine is opposite over hypotenuse. So the opposite side is 1, and the hypotenuse side, that's this one, is 2. But then they want to know what cosine is, a tangent, cosecant, secant, and cotan. So one thing hopefully that's obvious to you is that we're missing the length of this side. So we need to figure out that length of that side, and then I can fill in the blanks for all the rest of these. I could maybe do part of it right now. So cosine is adjacent over hypotenuse. I know the hypotenuse here is 2, so I could put a 2 there. I could actually put a 2 everywhere there's a hypotenuse. Okay, and then this 1 is the opposite side. I could do that over here too. Well, I know this one, and this one is 1. And that makes sense because these are reciprocals of each other. Opposite side is 1. Opposite side is 1. There. Okay, so I know at least one part of all of them. The only thing I'm really missing is what that adjacent side is. So to find the adjacent side, I can use Pythagoras. So here's Pythagoras. If you know two sides, you can find the third. This is a side C, so that's this one. So 2 squared is equal to this side over here. I don't have things labeled, but let's call it side B. So this would be side B. So I can put 1 here for side B plus a squared, I don't know. So 2 squared is 4 is equal to a squared plus 1. Subtract 1 from each side. Use the square root principle. So a is equal to the plus or minus root 3. I'm just going to use a positive because it's a length of a side, and negative doesn't make sense there. So a is root 3. So everywhere, that's this side right here, everywhere that I have an adjacent side, I can put a root 3 in for it. So this one's root 3, this is 1 over root 3, 2 over root 3, and root 3 over 1. So there are all my ratios. So if you know one, all you have to do is use Pythagoras, and you can find out the other ones. Now, one just quick little caveat with these. This one, and this one, and this one, and this one all look good to me. These two here look unsimplified to me. And the reason why is because they have a radical on the bottom. So it's a good idea, once you've figured out the ratios, just to go ahead and fix that. And like we did before, if you're rationalizing a fraction like this, you'll multiply both top and bottom by root 3. And so you'll have root 3 on the top over the square root of 9, which is 3. Okay, so the tan is 1 over root 3. It's also equal to root 3 over 3. And this would be preferred for tangent. Okay, to show you another one. Here they've given me the secant ratio of an angle. Okay, secant, not too familiar with that yet, but let me look over here. Secant is right there. So secant is hypotenuse over adjacent. But here I just have one number. I can express it as a fraction, and the number on the bottom would be 1. So that means the adjacent side is 1, the hypotenuse is 17. So adjacent is 1, hypotenuse root 17. Adjacent is 1, adjacent is 1, hypotenuse is root 17. And I don't know the opposite side. So this would be root 17. You can probably see the ones. Oh, I didn't do this one. Oh, that's one I have already. Root 17 over 1. So all I need to do is find the opposite side. So I can do Pythagoras. C squared is equal to a squared plus b squared. Now, I haven't labeled my triangle, but let's do that. So let's say this is my angle. So this would be the adjacent side is 1, and the hypotenuse is root 17. We can call this side angle B, angle C, angle A. So C is root 17. So root 17 squared is equal to A, that's this one, side 1. A and B doesn't really matter. You can interchange those. And then this side will be B squared, or the opposite side will be angle B, or not angle, side B. Okay, root 17 squared would just be 17 is equal to 1 plus b squared. Subtract 1 on each side. Ooh, I'm liking that number. Square root both sides. I get b is equal to the square root of 16, which is plus or minus 4. Again, length of sides, we'll use the positive one. So the opposite side here is 4. So on my ratios, I can just put a 4 everywhere there's an opposite side. And there. And again, like on the last question, I should take one, like this one here, the sine ratio. And the ratio, this is correct, that the ratio between the opposite side and the hypotenuse is 4 over root 17. But you should fix that. So you should multiply both top and bottom by root 17. On the top, you'll get 4 root 17. On the bottom, you just get plain 17. Okay, why don't you try one? Mark, get set, go. Press pause, and then press play once you're done and see if you're right. Okay, tangent is opposite over adjacent. So if this is my angle, my theta, opposite side is 5, this side over here is 3, I need to find the hypotenuse. So c squared is equal to a squared plus b squared. C squared is equal to 5 squared. Let's see. A, if this is B, A, and C, and again, like I said, it doesn't really matter, but I'll just be picky. And so this side will be 3, and this side will be 5. So this would be 9 plus 25, or 34. So C is equal to the square root of 34. And C is the hypotenuse. So over here, everywhere I see an opposite sign, opposite, I can put a 5, right? And adjacent is 3. And the hypotenuse, we just figured out to be root 34. You'll have to rationalize that one. Adjacent side is 3 over the hypotenuse, root 34. Tangent, I already have that one. Cotan will just be the flip. So it'll be 3 over 5. Sorry, that's way off to the side. Secant, now these ones, you You can look up what the hypotenuse and adjacent are, but you can also just say, well, it's a reciprocal of that. Root 34 over 3, or root 34 over 5. Okay, hopefully you're getting the idea with finding those ratios. Now let's do a bit of calculator work. And feel free to get out your decimals. Maybe I'll pull out some decimals here. All right. So I'll throw decimals over here somewhere. Okay, so with your calculator, I just want to see make sure you're okay getting these here. So sine 30, go into your functions and pick sine and type 30. Now, one of my problems here is that I type this out and I know that sine 30 is equal to 0.5, but I'm getting a wrong or a different number down here. This is not wrong. It's just that they are looking at the sine in terms of radians, not degrees. So it's important that either on your calculator or decimals, you make sure that you're in degrees, because typically that's what we're looking at. So to get into degrees, you just click that tool sign right there. Okay, not that one. Where was it? Oh, right over there. There's a tool on the right where the plus minus is, one right above that. And then down here, you'll notice we're in radian mode. So we want to change that so we're in degree mode. And notice that the thing changed for me. So the ratio sine of 35 is 0.5. Let's do cos. So cos functions, I'm doing cos of 45.707. Now I've found that with decimals, every time I go in, I have to change change it from radians back to degrees. So just be careful with that. Some calculators will stay in degrees once you set it there. Just be careful. Next one. Now this one, I wonder if decimals will do this. Let's try it. Okay, functions. Oh, they do have it. Secant. So I can hit secant of 60. Now let me think. Cos of 60 is a half. So this should be 2. Let's see if it works out. 60 comes out to 2. Oh, that's nice. It's nice to have that. Now, sometimes if you have a calculator that doesn't have a secant button on it, what you have to do with that case is you can say, well, that's the reciprocal, right? So I can say that's the reciprocal of cosine. And then on your calculator, you would just type 1 divided by cos 60 equals, and it should come out to 2. Decimals is real nice that it has that button for you. So this one, and maybe try this one. So this would be 1 over, the reciprocal cotan is tangent. So you can try that just on decimals or your calculator. I'm going to try it here. So functions, I need to say cotan of 30. Cotan 30. 1.73. Yeah, that's correct. So I could do it that way, or I could go 1 divided by the tan of 30. Tan of 30. Notice it gives you the identical answer. Anyway, it's good to be able to use your calculator to determine what these are. And these are relationships between sides. So opposite sine of 30, what that's telling me is that the relationship between the opposite side and the hypotenuse is 0.5, or you could call it 1/2. So if the opposite side is 1, the hypotenuse is 2. If the opposite side was 10, hypotenuse would be 20. So this here is giving me a relationship between sides. Let's try the other way, trying to find an angle. So here's some equations actually where they're asking you to determine what that angle is. So they're saying sine theta is equal to 0.866. Now, I haven't ever seen this in a book, but once you've done it at a time, you don't have to worry about this. But typically, if you're solving any equation, like 2x minus 3 equals 7, if I want to solve the equation, I have to isolate that x. So I do things. So I add 3 there, I have to add 3 there. So I'll get 2x is equal to 10. Then I want to get rid of this 2, so I'll do something on this side as long as I can do something on this side. And typically with equations that works. Here, what you're wanting to do is get rid of that sign. So the way you get rid of it is to do an arc sign. But if you arc sign this side, you have to arc sign this side. And on your calculator, you should be able to see a button like that. So really, theta in this case is equal to the arc sine of 0.866. Let's try that in decimals and see what happens. Okay, so I want to do functions, and I want to do arc sine. There's the button right there, of 0.866. There. Ooh, that doesn't look right. I know this is 60 degrees, and that number doesn't look right. Therefore, it looks like I need to change my thing to degrees. There, degrees. There we go. That looks right. So 59.997, call it 60 degrees. So this one, theta would be 60 degrees. Try that next one. Again, use decimals or use whatever graphing calculator you have, or a calculator. I'm going to go, so I need to arc cos both sides. So I'm going to arc cos and then root 3 over 2. Root 3, where's my root? 3. And then I'm going to go over a little bit, divided by 2. There we go. So the arc cos of root 3 over 2 is 30 degrees. So here, theta is equal to 30 degrees. Okay, try those other ones. It's nice, I think, in decimals that they actually have those. I've never seen those on, well, I have. There's certain calculators, the Texas Instrument, the high-end ones, do have arc cos, arc tan. Let's see if I've got an arc cotan. Oh, I do right there. Arc cotan of 5 divided by 2, 21.8 degrees. So the angle that gives that ratio is 21.8 degrees. Okay, go ahead and try that last one. See what you come up with. Functions, arcsecant. That one. Oh no, it's on the same line. Functions, arcsecant of 2.453. There we go. So 65.9 degrees, about 65.9 degrees. Those are real useful, those buttons on decimals. And like I say, most calculators do not have those. 99% of the time, I would say 99.5% of the time when students come, they don't have those buttons on their calculators. Okay, let's go to looking at a right triangle and determining some things from it, given some particular information. So here they want us to find angle A if side A is 7 and side C is 9. So I need to use those tools I did just before on my calculator and my knowledge of these ratios to figure out some information. So they say find angle A. Let's put A up here. C will be there, B there. B, of course, is a right angle. And they say side A is 7 and side C is 9. So that's this one. And they want to know find angle A. So they want to know what that one is. So when I look at this, and I've put some guidelines down below, first I always mark my angle. So that helps me know which side are opposite, adjacent, and hypotenuse. And then I have to determine which ratio to use. So this side over here is the opposite side, and this side is the hypotenuse. So I look over at my ratios to see which of those ratios include an opposite and a hypotenuse. It looks like sine is the ratio that I want to use. So sine is my ratio. So now I'll rewrite things. So sine theta, in this case is A, is equal to the opposite side is 7, and the hypotenuse side is 9. If I want to solve for A, I have to get rid of the sign. So I'm going to be doing the arc sine of 7 over 9. Okay, decimals. It's amazing how fast that comes out. Okay, so I want to do the arc sine of 7 over 9. So functions, arc sine of 7 divide 9. 0.89. That seems a little funny. Let's make sure we're in degrees. There we go. 51.1, call it. So that angle A is 51.1 degrees. So this angle there, 51.1 degrees. Okay, so that's how you could solve for an angle. Why don't you try one? Go ahead and find, again, angle A. Given that sides B and C are those. Press pause, press play when you think you've got it. Okay, this is angle C. We'll do a B here and an A there. They want us to find angle A again. They say side B is 3 and side C is 5. Okay, so I've labeled things. I've marked my angle. Determine the ratio. This side is my adjacent side and this side is my hypotenuse side. So adjacent hypotenuse has got to be cosine. Okay, so let's grab cosine. Whoops. Maybe I won't grab cosine. I'll just write it over here. So cosine of an angle is adjacent over hypotenuse. So cos of an angle, and this side it's angle A, is equal to the adjacent side is 3 and the hypotenuse side is 5. I'm looking for angle A, so I need to get rid of the cos. So I'll arc cos both sides. Again, on your calculator, do the arc cos of 3 over 5. This is getting smaller and smaller here. Okay, so arc cos of 3 divided by 5. And it's interesting that when you do it, when I keep popping up browser windows, it keeps reverting back to radians. So make sure you have yours in degrees. This would be 53.1. So the angle A is 53.1 degrees. Okay, now let's find an angle, or let's give an angle and a side and figure out a difference. So here I've got an example. Angle B is 45, so this one's 45 degrees. This one I know is 90. I guess I could figure that top angle out pretty quick. But this is my angle B. This would be A and C. Side C is 16, and side A is this one. So now I've got to figure out which ratio I need to use. I've marked my angle. The ratio needs to have, okay, this is hypotenuse in it, and this side right beside is adjacent side. So again, it looks like I'm going for cos. So cos of an angle is equal to the adjacent side over the hypotenuse side. Cos of 45 degrees is equal to the adjacent side, which I don't know, but I know it's angle, or side A, over the hypotenuse is 16. This time I'm solving for A, little a. So I want to get this by itself. So to get rid of the divide 16, I'm going to multiply both sides by 16. So then I just have to go 16 times the cos of 45. Let's do that quick. 16 cos 45, that's what I need. 16 cos 45. All right, 16 functions, cos. Notice it's not arc cos. I didn't have to arc cos anything here. And then 45. Again, make sure you go to your angle thing and make sure, get this out of the way. Make sure I'm in degrees there. So 16 cos 45 comes out to 11.3. So A is 11.3 meters, inches, feet, whatever it is. Why don't you try one? So there's what you're given. See if you can find side A. Mark, set, go. Okay, angle, this is angle C. We'll make this one A and this one B. I'm looking for, I know B is 25 degrees. Side C is this one, and I'm looking for side A. Okay, which ratio do I use? This side here is the adjacent side. This side is the hypotenuse side. Looks like I've got cos going again. So cos of an angle is adjacent over hypotenuse. So the cos of 25 degrees is equal to the adjacent side, which I don't know, over the hypotenuse, which is 23. So now I'll multiply both sides by 23. And again, notice there's no getting rid of cos. I don't have to arc cos anything. So now I just have to go 23 times the cos of 25. Again, let's see what decimals will say with that one, just to make sure you're on the right track. Okay, so I have to go 23 cos 25. Okay, frustration, because my thing is in radians. There we go. 22.98, call it 23. So this will be, A will be 23. 23 degrees. Okay, hopefully that's given you a bit of comfort or refresher anyway in solving for angles and solving for sides of a triangle. There's one thing that happens quite often in trigonometry, and that is we keep using the same angles, and you've seen a bunch of them already. And the angles that we use often are 30 degrees, 45, and 60. And sometimes, rather than giving an approximation like this, we ask for an exact value like this. And there's actually a table that we can make up for sine, cos, and tan of those angles that we use all the time. So here are some triangles that are written, and the ratios between sides are there. And let me show you how you can get this table. So sine, I know, is opposite over hypotenuse. So over here, say if I pick this angle there, I'll pick 45 degrees. Then the sine ratio is going to be 1 over root 2. So it'll be the opposite side over the hypotenuse side. So it'll be 1 over root 2. Now when you rationalize that, it turns out that that changes to root 2 over 2. The sine ratio, if you have a 30-degree angle, here's a 30-degree angle, sine ratio is opposite side is 1 over hypotenuse, which is 2. Now let me just complete this table quickly because I've memorized it, and it's not a bad idea to memorize them, just so that if a question ever has sine of 30 or tangent of 60 in it, you've got a table and you can use those to figure out the exact value of a particular question. Okay, sine of 60 is root 3 over 2, and you could confirm these with the triangles beside here. Cos of 30 is root 3 over 2, cos of 45 is root 2 over 2, cos of 60 is 1/2. Tan of 30 is root 3 over 3, tan of 45 is 1, tan of 60 is root 3. So there's a nice table to memorize. It's in the e-text as well, but maybe just write it down on a piece of paper somewhere so you can use it just in case you need it. Here's just a quick way that you could memorize the thing. The top row or the bottom row or the denominator of both the first and the second row is all 2's. That's fairly easy. And then notice the top goes 1, 2, 3, and then the second one is 3, 2, 1. But you have square roots on the numbers that aren't 1. And then the third row, I can't remember how to memorize that, but I've got it memorized. I don't have a good way of remembering it. Anyway, so root 3 over 3, 1, and root 3. And you can use those. Those are useful if you have a question, like just for example, say I have a triangle where this angle is 30 degrees. Okay? and then say this side is 4, and I want to know what this side is. So this will be the sine ratio. So the sine of 30 degrees is equal to 4 over x, because I don't know that side. Now I know automatically that sine is 8, because sine of 30 is equal to a half. So the ratio of 30 degrees, the sine ratio for 30 degrees is always 1 over 2, or the hypotenuse is always double the side of the opposite. And so if my opposite side is 4, x has to be 8. Another way you could figure that too is, you know, the sine of 30 is 1/2, and then you can solve that equation. So cross multiply and divide, whatever, but you're going to come up with x is equal to 8. That's just a basic example of when it's good to memorize those values. Okay, last concept is to look at how to convert things between degrees, minutes, and seconds. Here I just put a GPS coordinate system for the college. So we are this north and this west. And I show those measurements in 2 different ways. This first one is known as DMS, or degree, minute, second, and the next one is shown in decimal degrees. But it's nice to be able to convert back and forth between the two. Some calculators can do that. I actually haven't figured out how decimals can do that. But there are some graphing calculators that'll do that automatically for you. But it's not a hard thing. If you wanted to convert a DMS to decimal, what you do is, so these are degrees, minutes, and seconds. And the relationship between each is that there's 60 seconds in a minute and 60 minutes in a degree. So if I wanted to convert this here to decimal degrees, I'm going to start with the littlest one, and I'm going to go 39, I'll write it this way. So I have 49 degrees, and then I'm going to change these two to a decimal. So it'll be 39, and then instead of putting my minute symbol there, I'm going to say 39 over 60 minutes. Okay, so I'm converting this thing here, this thing, to minutes. So you just divide it by 60, and you come up with an answer to that. It'll be 0.6 something or other. Let me write it. So 39 point, I think it's 666 or something like that. It'll be close to that, minutes. Okay, not there yet, because I want it decimal degrees. I want it to look like that one. So then I take the 49, and now I'm going to figure out what portion of a degree this is. And to do that, you take your whole answer, 39.66, whatever that was, and divide it by 60, because there's 60 minutes in a degree. So when you divide those, I think you're going to again get like 0.66 or 0.65. But those now are degrees. So 49 point something. Actually, let me do it on my calculator. Okay, when you divide those, that comes out to 6.5. Okay, so this is 6.5. So then 39.65 divided by 60 is 0.6608. So then I add that to the 49, and I get 49.6608 degrees. So that's what this up here would be in decimal degrees. Now to go the other way, to take this and make it into degree, minute, second, you just change. Instead of dividing by 60, you multiply by 60. So I'm going to take the 112 and I'll make that a degree. And then the other portion, I'm going to take 0.8080 and I'll times that by 60, and that'll give me minutes. Let me do that. So 0.80, yep, times 60 gives me 48 minutes. Well, let me just write it the other way. 48.48 minutes. So I still have my 112 degrees out there. Now I've got 48.48 minutes. Now to get the seconds, I'm going to take this portion off. So it'll be 112 degrees, 48 minutes, and, 0.48 times 60 seconds. So what does that turn out to be? So 0.48 times 60 gives me 28.8. So I'll have 112 degrees, 48 minutes, and 28. You could put the 0.8, but let's just round it. So instead of 0.28, let's call that 0.29. 0.29 seconds. Okay, so that's how you can convert a decimal degree into a degree minute second, or a degree minute second into a decimal degree. So in this section, just before we do that, go ahead and try one. See if you can convert those. I'll do it again quick and see if you get it right. Okay, so I'm going to take the 22 and divide it by 60. Divide 60 gives me 0.3666. So 113 and 45.36, a bunch of sixes, minutes. Now I'm going to take that number, let's see, I have to add my 45. Okay, and now I'm going to divide that by 60. So that'll be 113.75611, and you can round it to whatever you want. Done. So divide this by 60 and then add it to this. And then take that number, divide it by 60 and add it to that. And then to go the other way, you just go backwards. So this would be 45 degrees, and I'm going to take the 0.325 times it by 60, gives me 19.5. So it'll be 19 minutes, and then I take the 0.5 and times it by 60, and I get 30 seconds. So this is decimal degrees, this is degree minute second. Okay, so in this section we've had a quick introduction to trigonometry. We've learned how to find any ratio, as long as I'm given one ratio, determine any of the 6 ratios. We've also looked at solving for sides or solving for angles. And lastly, we looked at converting decimal degrees into degree minute second or back. Try some questions. Give me a holler if you have any.